Hello friends, welcome back to another session of Core Java tutorials. Today we will see a program. So write a Java program to display the roots of quadratic equation ax square plus bx plus c is equal to 0. Calculate the discriminant d and basing on the value of d describe the nature of roots. Okay, so there is a quadratic equation. Quadratic equation is also called as a 2-degree equation. So which is like this: ax square plus bx plus c is equal to 0, and you need to calculate the discriminant. So there are some formulas that you need to calculate. So the discriminant d is equal to, so how do you calculate the discriminant? So discriminant d is calculated as b square minus 4ac. Okay, so based on the value of d, there are certain outcomes. Okay, so there are certain outcomes. The nature of the roots are decided based on the value of a d. Okay, so the first outcome is, so this statement will have certain outcomes. Okay, so the first is if d is greater than 0. Okay, so capital D. So capital D is greater than 0, and the next outcome is it can be equal to 0. And the next outcome is like it is less than 0. So there is a positive number equal to 0 and a negative number. Okay. So if it is greater than 0, then there are two roots. Okay. So there will be two roots and the roots are real. Okay. So the roots are real and there will be two roots. Okay. So the first root is minus b plus root of b square minus 4ac by 2a, and the second root is minus b minus root of b square minus 4ac by 2a. Okay, so this is the output that you need to print if the value of d is greater than 0. Okay, so if it is equal to 0, then the roots are real and they are same. Okay, so root 1 and root 2, here you can say this is root 1 and this is root 2. So in the first case, when d is greater than 0, then there are two roots. Roots are different and they are real. In the second case, when d is equal to 0, there is only one root. The roots are same and the roots are real. So there is only one root. Okay, so which is minus b by 2 into a. Okay, so this is the second case. The third case is where d is less than 0. Okay, so there is a negative number. Okay, so for the negative number, the roots are imaginary and they are different. Okay, so there will be two roots and the roots will be different. The root 1 and root 2 are different and they are imaginary. Like it is a complex number. Okay, because d is less than 0. Okay, so it will be minus b plus root of, okay, so minus d by 2 into a. So this is one root. Okay, and the other root is minus b minus root of minus d by 2 into a. So since okay, square root of negative number is not possible. Okay, so these two are the complex numbers. So you can in your output you can make it like this. Okay, so you can say plus and some d value, square root of d, and then some I over there, and this will be minus b minus square root of d, okay, positive d, and then I at the end. Okay, so you can make it something like this. Okay, or else simply you can print that the roots are imaginary. So this is how you solve a quadratic equation, my friends. Okay, so now we'll see what are the prerequisites. Okay, so to write this particular Java program, okay, so to write the program for quadratic equation, what are the things that you should be knowing? Okay, so the prerequisites for this is, because there are three outcomes. Okay, so there is a branching over here. After calculation of d, there is a branching. Okay, so either the path of execution goes in this way based on the d value, or it may go in this way, or it may go in this way. So the prerequisites is you need to know, the first thing is you need to know how to branch using if and else if. Okay, so because there are three things over here. Okay, so three paths of execution are there. So you need to know the else if ladder. So to write this program, you need to have knowledge on else if ladder. And the second one is, because these are all mathematical formulas to square root. Okay, so to square root a number and all that, you are already having predefined square root method. So you need to know in which package is this particular square root method and in which class this square root method is. Method is there in the lang package. In the lang package, there is a class which is math class. Inside this math class, there is a static method which is a square root, sqrt. Okay, so this sqrt method will take a double as arguments. So you have to pass a double value as argument and it will give the square root. Okay, so it can't give square root of a negative number. If you try to give a negative number and find out the square, it will give nan, which is not a number, as the result. So you always have to give a positive value as parameter inside this square root. So this knowledge you need to have. And the third one is how to format your output, because this program deals with mathematical equations and the outcomes are also double values. So you need to know how to format your output properly. Okay, so to format the output, I am trying to use the printf method. Okay, so I'll be using system.out.printf to actually format the output accordingly. Okay, so I'll be deciding how many numbers after the decimal value I need. Okay, so that facility I have using the printf function. So with this knowledge, let us write the program. Okay, so let me start to write the program. So we'll decide on what are the packages that we need. Okay, so since this square root is there in the lang package and the lang package is by default added into all the Java programs, you don't require to explicitly import this particular lang package. But since we'll be reading, because it's ax square, the quadratic equation is ax square plus bx plus c is equal to 0. So these are the known variables. Okay, so a, b and c you have to read from the user. Okay, so read from the user. To read these a, b and c, we need the scanner class. And the scanner class is there in util package. So you need to import the util package. Okay. And make sure while reading, okay, so a should not be equal to 0. Okay. So that interactive statement you should include so that the user is not entering 0 for a. Because this is a quadratic equation. Okay. So it's a 2-degree equation. There should be x square. So I am importing the util package. So import java.util.star. Okay, so now I am writing my class. The class name is Quadratic. So inside my class name I am writing the method, main method, public static void main. Okay, so now I am declaring the variables. Okay, so I am making them, those are the real numbers. So I am making them as double, a comma b comma c, and also we are calculating the roots. So root 1 comma root 2, and also we need to calculate the discriminant capital D. So I am putting a D over here. And also in case if it is an imaginary number, we need to calculate some imaginary value. So I am saying img. Okay, as of now I require this. If I want some more, I'll add them to this particular declaration. Okay, right. Now I am declaring object. I'm creating object for the scanner class. So I'm saying scanner SC is equal to new scanner, and I'm saying I'll be reading the input from the keyboard. So I'm saying system.in. I'm passing this as argument into the scanner constructor. Okay, so now the scanner object is created. Now I'll be reading the values of A, B and C. For reading that, I am writing as an interactive statement, which is system.out.println, and I'm asking the user to enter A. And you can also write some other interactive statement saying that A should not be 0. Okay, so it should not be 0. So you can also mention that. And now I'm reading. So I'm saying A is equal to SC dot. So since this is a double, so I'm using this next double method. Okay, so by doing this, the input from the keyboard is read into the variable A. Likewise, write for B and C. Okay, so I have written statements, okay, for reading in the values of B and C. Now we'll calculate the discriminant D. So I'm saying capital D is equal to B square, which is B into B, minus 4 into A into C. Okay, so D has been calculated now. Okay, so once the value of D is calculated, now we have to write the branching. Okay, because based on the value of D only, the path of execution is decided. So herein I am saying, okay, so if capital D is greater than 0. Okay, so I am just starting with if it is greater than 0. Now there are two roots to be calculated. So I am saying root 1 is equal to, so what is root 1? So we are having a formula, right, which is minus B plus, okay, so what it is square root, right? So to use square root, I have to say math.sqrt. Since sqrt is the static method, I have to use it with the class name. So that's why I said math.sqrt. So sqrt, what it is capital D, divided by what? 2 into A. So I'm putting it in bracket. So, and there is a semicolon at the end. Okay, so by doing this, root 1 is calculated, is also calculated. So we are using the same formula, but here it is minus. So math.sqrt and square root of discriminant by 2 into A. So both the roots are calculated. So we'll write a system.out.println statement and say, so I'm writing system.out.println and I'm saying the roots are real and different. Okay, so the roots are real and different, and now I'll be printing the roots on the console. Okay, so to do that, I can also use this system.out.println and do it directly. But since it's a double value, after the decimal point, there will be so many values which will be printed. So I don't want all of them to be printed. I just want only 2 numbers after the decimal to be printed. Okay, so to do that, I'll be using system.out.printf method to actually format my output. So I'm saying, I'm writing that. So I'm saying system.out.printf, and which is very much similar to your C programming. So now I am saying root 1, okay, is equal to, so I am saying percentage point to F. Okay, so I am saying point to F, and root 2 is equal to percentage, this is type conversion, so 0.2 f, you can decide on how many you want after the decimal. Okay, so here I'm saying I just want two numbers after the decimal. Okay, f. So the roots, root 1 is this and root 2 is this. Okay, so double quotes, comma. Now I have to tell what is this percentage f. So this percentage f is this root 1, okay, variable, and the second one is root 2 variable. Okay, so I just have written this statement and the output will be printed on the screen for us. So that's it with this particular block. Okay, so I'm putting a closing bracket over here. So if d is greater than 0, all these 4 statements will be executed. Okay friends, so this is the first condition. What is the second condition? The second condition is where the discriminant is equal to 0. So we'll see that part. So I am writing else if, okay, so else if d is equal to 0. If d is equal to 0, the roots are same and they are real. Okay, so now I am calculating. So root 1 is equal to, so which is minus b divided by 2 into a. Okay. Okay, you can also use this chain of assignment over here. So I am saying root 2 is equal to root 1 is equal to. So you can also have something like this. Okay, so write a interactive statement. Tell the user what it is. So I am saying system.out.println, and I am saying the roots are real and same. Okay, so the roots are real and same, and you can also print the roots. Okay, so you can also print the roots and show it to the user. So I am writing the same kind of statements that I have written previously. Okay, I am saying root 1, okay, is equal to root 2 is equal to, then I am saying percentage 0.2f, and I can simply print one thing, that will be enough, or else you can separate it and also print it. Okay, right. So this is when the discriminant will be equal to 0. So these statements will be executed only if discriminant is equal to 0. Okay, so we'll see the third case. The third case, since there is only one case left, I am writing an else here, over here. So this else means that d is less than 0. So the value of d is negative over here. So let us see how to process it. So when the value of d is less than 0, so the roots are different and imaginary. They are not real. Okay, so they are not real, meaning that they are imaginary and they are different. Okay, so you will be having two roots, root 1 and root 2, and they are imaginary. So to calculate that, so we are saying root 1 is equal to, so I am saying minus b by 2 into a. So this is the real part. So we are calculating the real part as minus b by 2 into a. And the imaginary part, so I have already declared a variable of double, which is img, and now I need to find out the square root of d. Okay, so math dot sqrt d, okay, divided by 2 into a. So this is the imaginary part. Now can you tell me what is the mistake? So there is a mistake in this particular line. I want you to pause and think of what is the mistake in this line. Okay, right. So the mistake is, recollect what I told you in the beginning of the video. In the beginning of the video, I told you that square root cannot take negative value as input. In case if it takes negative value as argument, okay, so it will give an answer which is NaN, which is not a number output. Okay. So you cannot pass d here in this case, because this else will execute only in the case when d is less than 0, meaning that it is negative number. So this statement will not work. It will work for you, but the output will be NaN. Okay, so generally according to the formula, okay, so what will be the root of negative value? For example, the root of minus 16 will be equal to 4 and then an I, okay. So in the same way, okay, so the root of minus 4 will be 2 and I, okay. So we'll apply the same case over here. Now what I will do is, since this will not take the negative value, I'll reverse it and I'll make it minus. So minus into minus will make it plus. So D, the value of D that will pass over here will be a positive value. Okay. So I'll add an I at the end to represent that it is a complex number. I'll show you how to do that. So I'm writing a system dot out dot println statement, and I'm saying the roots are imaginary. You can simply write this and ignore the other parts. You can simply write this statement and needn't write all this, but I'm just trying to explain you about NaN, okay, to make you aware with the concept of NaN. I'm just writing these statements, else you can simply write roots are imaginary and end this program, right? So now I'm writing a system dot out dot printf statement. Inside the printf statement, I am saying root 1 is equal to, okay. So now the first one is the real part plus, okay. So I am saying a plus and percentage D point to Fi, okay. When I do this, what will happen is this particular part is this root 1 and this particular part is this imaginary, and by adding I it will represent a complex number, okay. So now I am saying this particular percentage F is root 1 comma this percentage F is this IMG. So I am saying IMG. So the first root is printed for you. In the similar way, I am writing another system dot out dot printf, and I am writing in the similar way. So I will be saying root 2 is equal to percentage point to F minus percentage point to Fi, okay. And the first one is root 1, okay, or you can simply say root 2 is equal to, because it's same, the real part is same, so you can simply say root. So here you can say root 2 comma IMG to be very specific, and that's it. So this will execute. So after this else, we are closing the main method and then I'm closing the class, okay. So this is the entire program, my friends, okay. So there are three outcomes of the discriminant. One is when D is greater than 0. The other one is when D is equal to 0. And the third case is when D is less than 0. Okay. So I'll show the execution of this program.